Live. Now we're live.
All right. So, kudzu is a plant that was imported to the United States from Japan. Now covers over 7 million acres in the south. Contains chemicals called isoflavones that have been shown.
What on earth are you reading?
Lesson 14.
Lesson 13, you mean?
No.
Oh, no. Lesson 14? What the? No. Oh, yeah. Oh, sorry. I was back in lesson 13. What question is that?
Question 1.
Why does yours sound different? Start reading it again.
Kudzu is a plant.
Not the same.
No.
No. My question one,
Oh, this is the homework.
that is.
I opened the book on accident. That's my fault.
Can you save that? Can you close and save that?
Nope, I have to keep it. I'll just leave the tab open. That's fine. I should really finish it tonight anyways. Okay, sorry. I'll start a new one. I'll start the group meeting one.
Yeah, that'll work. I was just confused.
Okay, in an ANOVA hypothesis test, we reject HO when there is sufficient evidence to indicate at least one mean is different from the others. All the means are equal.
You just read the answer, actually.
All the means are equal.
In HO, all the means have to be equal. So, evidence to,
we do reject it if one mean is different from the others.
So 3 is?
True.
True. Perfect.
4. What requirements need to be checked when performing an ANOVA hypothesis test? Sample means are positive. Data in each group are normally distributed. Variances are equal in each group. None of the above, B and C. I feel like B is true. Like data in each group are normally distributed is true.
B is true.
And C is true as well because the mean has to be equal, right?
B and D.
Wait, what?
Yeah, B and C.
B and C. If each group is normally distributed, do the following. Construct a scatter plot of the data. Each group, create a histogram, construct a QQ plot. To check if it's normally distributed, you would do a histogram. No. What's a QQ plot again?
We learned about it this week. Which is basically, it's a little dot graph. I don't know.
Oh, I see it now.
Yeah.
That's what it is. That's the answer.
QQ, yeah, exactly. That's the only reason I knew it was that, because I thought, well, we learned about these, so.
Oh, it's the weird little box one. It's the one that has like the. Isn't that the same as like the one that shows the 50th and the 25th and the 75th percentiles?
It is not, but that is what Amy thought it was as well. I think that's a box and whiskers plot.
But they look the exact same.
Not the QQ plot. The QQ plot looks pretty different. Because you're looking at the, I mean, I see what you're looking at on screen. The QQ plot in this, I don't think we have a picture of one.
But you know what I'm talking about, right? They felt the same. Okay, we assume the variance in each group is the same if the following happens. The sample variance for each group is smaller than the sample mean. The largest sample standard deviation is less than 2 times the smallest sample standard deviation. Each group has the same sample size.
Oh.
Yeah, it's the last one. No?
Oh. No, I was asking if I lost you. I couldn't hear you. Number 6.
I think it's each group has the same sample size.
I would recommend against that answer.
Okay. Then the sample variance for each group is smaller than the sample mean.
Probably not your best choice either. If we go, where's my thing? Invariance, go to the homework. I can't, unfortunately, because I only know it because it's in the reading. The answer to this one is right in the reading. So go to the homework and go to 3.2, requirements for ANOVA. Rather than me say it, we're going to make you find it.
Thank you. I seriously appreciate this so much.
3.2, requirements for ANOVA, and don't even worry about it.
If the largest standard deviation is less than or equal to 2 times the smallest standard deviation, we conclude that the variances are equal. Less than or equal to 2 times the standard deviation. So it's the largest sample standard deviation. 2 times. Or is the largest sample?
So B?
Largest standard deviation. Yeah, it's B for me. I don't know if it is for you. But it's the longest answer.
Mm-hmm. Perfect. You nailed
it. Thank you. You're a really good teacher. An ANOVA hypothesis test is equivalent to conducting independent two-sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs. 1, 2, 1, 3, 2, 3. How many pairs are there when there are 4 samples? 4 pairs.
No! That's
okay,
what
stop.
I want.
Don't tell me.
What? I want to tell you the answer,
Don't
but
tell me what
this
the
one
answer.
I can't explain how to get there.
If there are 3 samples, there are 3 pairs. How many pairs are there when there are 4 samples? Oh.
I really wanted it to be 4 as well.
There's 3.5
but I thought it over
pairs.
and figured it out. There is not 3.5 pairs. What it's asking is how many, when it says a pair, stop guessing. There are, you have to line up each one. So see how 1 with 2, 1 with 3, and 2 with 3. That's for 3. So for 4 pairs, you have to get all the numbers together. So 1 with 3, 1 with 4. So you tell me how many. I had to write them down.
I'm writing it right now.
If you write it down, you can do it.
And then we have to, and then 2 has to be with each one as well? Or 1 has to be with all of them?
I mean, first one should be with everything, 2 with everything, 3 with everything, and 4, just everything with everything.
Except for itself.
It's perfect.
So 1, 2, 3, 4, 5, 6. I got 6.
That is the answer.
Oh, it is? Okay. Like, I better double check, but I don't know how much further I could go with it, because 4 has already been matched with everyone. Yeah, 6. That's interesting. So if it was 5 samples, you'd do the same thing, right? 1, 2.
Uh-huh. Would be 11, I think. No, 11, 12, 13, 14. I don't know. I'd have to write it down.
It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Is it 10?
It's 10. Yeah, which is funny. It's double. That's so the pattern, like each time, for each set number, it decreases 3 pairings of 1, 2 pairings of 2, or 3 pairings of 2, 2 pairings of 3, and 1 pairing of 4.
Yeah.
So it has a pattern. That does help to like write it out though.
Yeah, for sure.
The soccer shoes data has 6 groups: A, B, C, D, E, socks.
I enjoyed that as well. I'm glad you. Amy didn't like it. I also chuckled at it, but she didn't care for it.
I feel like she would laugh at something like that. You
She
don't
was
have to bug her about
she was all business tonight.
it. She just wanted to get it over with.
Yeah.
We found the wiki. Load all 6 samples into the quantitative inference procedure spreadsheet or perform a ANOVA test in SPSS. We don't use SPSS, do we? And
What?
observe that the p-value is 0.0809. Okay. Let me open it. Okay. That means I have to do my homework tonight. That's probably better for me though, because then it's like still fresh.
Yeah.
No. What is it called? Socks?
No, it's called soccer shoes, is what the data file's called.
What does socks stand for?
What's their sock size? I don't know. I couldn't decide.
Put my quantitative thingamabobber. Is it the quantitative inference procedure?
Yes, I have it open. Let me
Yeah.
check. Yeah? Yeah. Yes. But you will also need quantitative descriptive statistics later on. So you might as well open them both.
Right. That's really weird. Okay. Color and accuracy. Did yours have like 120 lines?
They're all in the 30s, right? Ish.
Huh?
They're all like around the 30s though. Is that the numbers you're looking at? Like 35, 32, 40, 20?
Oh, I just copied it. Let me
Uh,
paste it real quick.
what you have to do though is you do have to break them into their groups. Because if you look at that, where'd my soccer shoes go? If you look at soccer shoes, the one on the left, the one that says footwear, there's an A and then there's a B. Do you see that?
Mm, I don't understand. So, do I put it in the ANOVA spread?
Paste it like 6 times.
I know. Do I paste it into the ANOVA spread though? Into
Yeah.
that tab?
Uh-huh. Oh wait, ANOVA spread or is it just ANOVA, isn't it? I don't know. I got too much stuff open.
It
A
doesn't spread. It just is ANOVA. Wait, so I just take chunk A and put it like in variable 1.
Yes, exactly. And then chunk B in 2 and socks in 6.
So I don't even need to copy in like the letters A.
No, you don't need just the numbers. I think if you take the letters, it'll mess it up probably.
Probably. Just guessing. Copy. Did you remember to put the link up from you and Amy's meeting?
I did.
Good. Sorry, this is time consuming.
No, it is for sure. Don't even worry. I'm just hanging out, so I'm fine with it.
Alright, okay, I got them all in. And
What's your p-value?
my p-value 0.0809.
9?
09
Oh, yeah.
458. And when I hover over it, it says Craig Johnson.
I don't know why it says that. Don't hover over it. All right, so the question just has you remove socks and then type in your new p-value. Where'd my answers go? Dang it.
How do I just clear? Oh, I guess I could just undo. There it is. Okay, I got 0.3092.
That's mine as well. Yeah, and it's rounded to 3.
Wait, why 3? Because mine's 30920.
Sorry, rounded to 3 decimal places.
Oh, okay.
I
0.3.
Yeah, that was my fault. I ended the sentence after half of it.
Okay, the p-value always goes up when only one group is removed compared to the p-value when all the 6 samples are included. False.
False?
Yeah, because the p-value went down. Oh, no, it didn't. It went up. Does it always go up, though?
It was false. You got it, I think. Where'd my... I need my last block. I have mine just in screenshots. Yeah, 9's false. I mean, you got it right. But the only way to do it is, I mean, the only way that we figured that out was to remove a couple of them. I think when you remove group
That's
2,
what I'm doing right now. And when I'm removing them, like, they're all just different.
yeah.
False. What is the highest p-value you see when removing only one group? Wait. The highest one. So I have to remove lots of different groups.
When it says a group, it's the whole. It's all of like variable 3. So you highlight the whole thing, and then you have a Mac, right? So you double click or use 2 fingers to click on it, and then one of the options in the drop down menu is clear contents. So if you highlight all of it, then you clear it, then it'll clear all of them at once.
It tells me I can't do that.
What? Why not? Are you highlighting the word variable 2 as well, or just the numbers?
Oh, wait. Hold on. There we go. I highlighted all of box C. Okay, I got 0.4477, removing variable 3.
I think that's your highest one.
I have to know, though, for sure.
Yeah, keep going.
And besides, practicing will, like, help me. Because
Yeah.
I want to do well on the homework and the test. Like, I'm so sick of flaking.
I'm sick of getting terrible scores on the homework as well.
The, like, professor offered to go over them with me, but I'm just never, like, I'm never around at reasonable hours for people, you know?
Yeah.
That makes me feel bad. Like, I don't want to ask her to meet at an unreasonable hour. Okay, it looks like removing variable 3 is the best one. Clear contents. 0.447 or 0.448.
Perfect.
When all 6 samples are used, what is the minimum standard deviation? So, well, back. 5.230.
Yep.
When all 6 samples are used, what is the maximum largest standard deviation? 7.291.
Yeah.
The test for equal variances is satisfied for these data. Test for equal variances.
Remember how we decided the variance thing? It had something to do with standard deviation.
Right, okay. If the largest standard deviation is less than or equal to 2 times the smallest standard deviation, then we will conclude that the variances are equal. So we multiply 5.23 by, or 216, 5.216. That's the smallest one.
Yep.
I put 230. Whoops. Okay. So if you multiply it by 2, it's 10.4 something. 10. Yeah, 10 something, and that's larger than the largest standard deviation, which is 7.291. So the test for variances, for equal variances, is satisfied for the data.
Yeah. Perfect.
Construct a QQ plot for each of the 6 samples. Each of the samples are approximately normal based on what you see in the QQ plots. Where do I go to do a QQ plot?
QQ plot, you have to open the quantitative descriptive statistics.
Oh gosh, okay. Oh, QQ plots. Then what do I do?
So then you have to take one variable at a time. So highlight variable 1 minus the word variable 1, so just the numbers.
Okay. Then copy it.
Yeah, copy that, and you'll paste it into the QQ plot.
It looks really ugly.
It looks really ugly. So then you have to do that same, like, 2-click, right-click, and you have to go down where it says sort, and you have to hit ascending. And that should make it look a little bit more like a line.
Ah.
Did you get it?
Yep.
Cleaned it up real nice. And so what it's saying here, let's go, I'll just read it out of the lesson. It says, what does it say? Q-Q. It says we check by creating a QQ plot for each group. If the points in the QQ plot do not show a distinctive curve, then we can conclude that it's normally distributed. So on variable 1, do you see a distinctive curve?
No.
No is the correct answer.
It has a.
It's not.
Okay, that's what I said.
It's not perfect.
It has like a, but it doesn't have like a dip or a curve or anything.
Yeah.
Not like the. What's that thing we always use? That funny looking graph with the tails.
The applet.
Where you can highlight. Yeah, the applet.
Yeah. Yeah.
So do I take the other ones as well?
What was that?
Do I do the other ones as well?
Yep, you have to do each one. So basically you say 1 doesn't have a curve, so we're good with it. So then do each one. And tell me if any of them have a curve. It's pretty boring. Pretty tedious.
Curve.
What?
B kind of has like a funny looking gap in the middle.
We're looking for like the applet curve, if you want to know the truth. Oh, whoops. So if it looks, I mean, because yeah, B's got that weird gap. I have it all pulled up still too, but it doesn't really have a super distinct curve.
Do I have to do the socks one as well?
Gotta do socks as well.
Something. They're all looking pretty much straight.
What about the socks one?
Hold on, I haven't pasted it yet. Paste.
I just want to get your opinion on it.
Sort. It has like a. It looks like it kind of goes. Well, I guess mirroring it would be like that, or like that. I'll draw it.
Draw. I can look at it. No, you draw it. I want to have you draw it.
Like that. Like it could.
Let me pull it up.
Right here.
I think you made it a lot more intense than the curve actually is. I think you did a terrible drawing.
It's so beautiful.
Let me see. Ascending. All right, I kind of get what you're getting at. Yeah, it kind of has that shape. Your drawing's still a little too intense.
I feel like you would actually have to have points along the arc for it to count.
Yeah, I think for a curve, what it's looking for is it like goes up and then back down. And for that one, yeah, we discussed this one. We actually discussed the socks one quite a bit more because we said, that could be a curve, but it doesn't. It doesn't have a curve.
Right. So, true. They are approximately normal.
Yeah.
No. Yes.
Wait. True? Yes, true. Wait, that's 13. Do I have 14? Let me pull up my answers again.
Is normal with the curve, or is it normal if it doesn't have a curve?
Restricting a kid. They're normal if they don't have a curve.
So it is normal. So
it is.
true.
It is normal.
Okay. And then 15. The test statistic for an ANOVA hypothesis test is an F. What is an F statistic?
An F statistic is the statistic we get in the ANOVA thingamajig. I don't know. It had a description in the reading. It was just for the ANOVA test we use the F statistic. And I read the description of that, but it was in the index, wasn't it? Yeah, it was. It's a statistic of multiple variables. Something like that.
To the right or to the left of the F statistic? How would you even know that? Oh, I get it. Okay, wait. No, I get it. It is to the left because it's less than the F statistic.
Yeah, let's not get too confident with that one.
Really?
Yeah, I'm afraid so.
What's so good about my answer?
What? I know, the confidence was amazing. I loved it. You sent it, you stuck with it, but it's wrong. It's wrong.
Okay. Do you want to explain to me?
It's in the reading. It
Okay.
says, it just says for F, let's go to 3.1. Do you have the reading open still?
I do.
We're going to 3.1.
Okay.
Read it all. Out loud.
It is right skewed. The values of F are never negative. The p-value for the ANOVA test is the area in the right tail.
Nailed it. So, what's our answer going to be?
Always the right tail. Okay.
The right tail for an ANOVA.
And I'm submitting. And I got 1,000,000%. Perfect.
Boom. Perfect.
Yeah, thank you so much, Addison. Seriously, I appreciate this. Like, I'm sorry I was so late with my work meeting and everything, and I really tried to make it, but I'm glad that you stuck around. I appreciate it. I'm glad I caught you. That was so random. I thought you guys were still meeting. I was like, hello.
Yeah, that's super random. I just didn't exit out of it. I just had it open in a different desktop just doing its thing, and all of a sudden somebody was talking to me. Hello? What the heck?
It was meant to be.
I guess so.
But just
It
so you
gave me
know,
a chance.
I can still see you. Not to be a creep or anything, but just make sure you close that from now. Just
Yeah.
in case.